Well, here is a very densely populated board. It actually came from a signal processor. It's got a couple of DSPs. Let's have a look. So they are, whoops, steady. They are TMS 320C10s. So yeah, they're digital signal processors. They're full-blown CPUs. Actually, really nice bits of kit. This is used as a dense signal processor of some kind. Not quite sure what, but there's a couple of headers there. So this is a dual channel board of some kind. I didn't really get it for that. I was interested in it was very, very cheap. I think it cost about 10 quid or something, 5 quid. It was really cheap. And I was interested mainly the fact that it was absolutely stacked with 74 series chips, logic chips. So that's great. There's a lot of logic there, a lot of components. I was also going to sort of dick around with these a little bit and see whether I could get them booted and whatever. It's also had quite a nice little LED, sort of side mounted LED thing. So I might even try and take some of the other components off the board. A lot of these little suppression capacitors, smoothing capacitors for all the ICs. You know, it's cool. It's a good thing. It's a useful thing. I'm never going to be using this board, so I'm not fussed about damaging it. But what I would like to do is to start harvesting these components and testing it. Now, one of the great things about this unit, you can get these really cheap off the internet, is they are very, very useful for obviously programming ICs and reading ICs, either E2 proms, EPROMs, whatever you like. Even things like serial E2 proms like that, which came off a motherboard. That's actually really nice. But what's also great is you can use it for testing logic chips. So you can take any of these devices off there, even ones where it's rubbed off, and do an auto find. It will find it in the library and run tests against it. And from what I've seen so far, it's pretty reliable. It's never going to be 100% accurate in terms of full-blown testing. There may be edge cases where a chip goes a bit funny. You do some testing and actually it doesn't work very well in a real circuit. But I haven't actually found that. It's actually been pretty reliable. So I'm going to pull a whole bunch of these chips off here, and we should end up with a lot of potentially useful chips. I mean, some of them are a bit more esoteric perhaps, but there are lots of standard useful chips in here for other projects. I mean, right down to there's a 7400, so you know that is pretty standard chip, 7408. But there's also other chips. So there's 74574. So I think some of these are like octal latches and with rising edge and all sorts of stuff. So some of it's a bit more edge case, a bit more niche, I guess. But there's still a lot of components in there that are going to be standard 74 series chips, potentially very useful. So I'm going to put a bunch of these, and then we'll go over to the workstation, the workbench, and we'll plug them into here and do some testing. And actually, it's pretty good. Yeah. I think you'll like it. Here's the mess I've made. So there's a whole load of chips ready to go. There are those processors I've kept. I'm not sure what I'm going to do with those, but we'll see. And there's a EPROM there that I'm going to keep. There was actually other EPROMs that came off. I'm not sure. I think one of them is missing. I'm not sure. The standard is sort of low and high, so it's probably lower bank, higher bank. And anyway, I can't actually read anything off these. I think they're broken, so I'm not quite sure, or this doesn't quite support it. Anyway, let's focus on logic, and then we'll go on the bench. Right, oops, right, here we are back on the bench. We have our testing device here, all ready to go. I've actually put a chip in there already. This one is a oops, that way around, is a 74AC00, so pretty standard bit of kit. I've got my dish full of chips to test. So what we're going to do is we're going to do some testing. I've got a spreadsheet here to capture what we've got. So this is the 7400. So what we can do in this system is click on the logic testing bit, and we can do an auto find, and it will see what it thinks are best matches. So that just narrows it down in case things are difficult to read. So let's do a 7400 on there. Do that, and then we run the tests, and that says it's all normal. So according to this system, that test is done. You see when you click that, you get a little flash, and it runs the logic tests. Everything looks good. So that was a success. So what I'm going to do is put that in the good parts pile, and then we are gonna so yeah, we're gonna look that up as well. 74. So that is a quad to input NAND gate. I need to find a nice resource. Well, yeah, okay. So quad to input NAND gate. So get that in there, and then we're going to put that just so we can track what it is. We got a quantity so far of 1, and that's good. So that's the first one done. Let's pick another one, and that is a something 7474. 7474. That is a dual D flip-flop. So again, we could do an auto find. So it only finds 1. That's good. So 7474. Run the test. That also looks good. So 7474. And then copy that into there. So we've got that one, and so on. And basically, we go through all the chips. I'll go through all the chips, and we'll have a look. I'll just pick one of the larger ones, one of the physically larger ones, and we'll go there. So I can easily read that one. That is a 74244. 74244. Oh, 74244. What did I type? No, that's not found in the data sheet lookup. Let's do an auto find on here. 74244. 74244. Okay, that looks good. Doesn't actually tell you what it is. That would be good, useful if it could actually tell you what it was. Let's do another search online just to see, because I don't quite know why that's not found. 74. We've got one of them, but what is it? What is it? Ah, Octal 3-state buffer line driver receiver. Okay, well that's interesting. Okay, Octal. So it can be a bit tricky to actually find both the data sheets for all this stuff and whatever. Anyway, you get the idea. So I'm gonna go through all of these and see which ones are good, which ones are bad. If there are any bad ones, then we can go through that and together and see what it looks like when you're running a test and there are bad things going on. Sometimes you'll see on here, you'll see some erroneous pins, or you'll see some failed results in the tests that it's performing as it goes. So yeah, I'll check back with you in a minute. Okay, so I've done a bunch of testing and compiled a spreadsheet of stuff. Good news is that we've got, what is that, 34 working devices, all kinds of different things. Some of them are a little bit esoteric, as I mentioned earlier. I'm not sure what use I could make of them, although the flip-flops are always useful. But in terms of the other ones, yeah, that's really good. I think 34 is a great haul. There are 3 chips that failed, so we're going to take a look at those in a minute, and how the failures are reported back by the application. So that's really good. There are 2 other chips that are unknown, or at least not supported by this program. So we'll come on to that at another point. So let's pick one of these failed chips. So this one is the 7411. Make sure I get it in the right way. The 7411 is the 333 input AND gate. So if we go into there, so 7411, okay, and we do a test, you can see a failure there. So it passed on 7 of the tests, but the 8th test failed. Could very well be that we could pick one of the gates and ignore it and just use the other 2 gates. It says here it's a triple 3 input AND gate, so the chances are we may be able to use it. Now obviously if there's an issue with the IC, it's probably good practice just to ditch it. You could use it in extremis, I guess, if you really had to, but yeah, it's probably really for the bin. So that's that one that has failed. Let's pick another one. This one is 7410. So this is a classic chip 3 input NAND gate. So do that there, and then we test that. Same kind of failure. So there's another problem with that one, and then the last one, I think this failed a bit more. So this is the 7408, which is the quad 2 input AND gate. 08. Yeah, that really is bad. So I mean, that's not going to be doing anything for anybody. Anyway, so you can see here that it's kind of a useful test, a useful way of harvesting parts. If you have to buy these chips, I mean, they don't cost very much money, but you know, this would go to a landfill otherwise. And for the sake of it, we've got 34 chips at work, 3 that don't. That's not a bad ratio for kind of, you know, home hobby projects. I don't think it's a bad way of getting components. Obviously, you know, the components are going to be pretty random. It's going to be a mixed bag as to what you get. But yeah, it's great fun. And this little tool for doing the analysis is really useful. I found it super reliable so far. You know, if this thing says it works for my logic test, brilliant. So there we go. That concludes this video. Next time we're going to look at some more component testing, possibly using this device, possibly using my multi-tester, testing some capacitors, resistors and transistors, MOSFETs, things like that. So yeah, see you in the next video. Cheers.